What is built in the context of the Safe for DevOps Health Radar? Please note that everything that I'm going to say and everything that I'm showing you is under the copyright of Scaled Agile. Please also note that the Scaled Agile framework is a framework. Use it as a toolbox. Take out what fits your needs and what solves your problems. In my previous videos, we had a look at the Safe for DevOps Health Radar, which you can see here. We also identified that this is a process. The process starts with the customer. There we have the ideas from customer side, but also from business side. We use these ideas in the hypothesis step and create epics with a clear hypothesis statement behind it. With these hypotheses, we are going into collaborate and research, where we interview the customers, we try to identify the real customer need, and we also do market research. Then we define the minimal architecture to prove the hypothesis. And then in the synthesize step, we create a vision, a roadmap, and a set of features to address the customer needs. After that, we are going into develop. We are creating out of the features user stories, and then we are going to implement them. After the develop step, after we have committed the code, the build step starts. Now let's have a look what we are doing in the build step. From the develop step, we have now committed code. What we now need to do is to continuously integrate this new code, test the code, and create a deployable artifact out of that code. The goal of the build step is to create this deployable artifact with building quality. But we do this, all of that, because we have code on our side which we have committed, which now needs to be reintegrated with the rest of the code, and we also need to check the quality of that so that we can create this deployable artifact. We do this by reintegrating the code of every developer with the rest of the code. This reintegration of the code with the rest of the code should always trigger a build, should trigger the code analysis, and also the testing. This is done by a continuous integration server. Every commit to the version control should trigger a build. After that, we need to execute the unit tests and then also the code analysis and also the security code analysis, which is a static code analysis. After that, we need to get feedback to the developers as fast as possible so that they know if their committed code was okay or not okay. One of the common sources of problems is long-lived branches. What we usually can see is that teams are working on long-lived branches and then try to reintegrate after a sprint on the last day. This is, in most cases, not very successful and causes a lot of problems. What we need to do is merge back as fast as possible so that we have one branch where the current version of the software is in. It is in the responsibility of the development team to decide what kind of branching strategy they will follow, be that trunk-based development or Git flow. The only important thing is that we can merge back as fast as possible so that we have one version of the software which we can continuously integrate. A broken build affects other team members and also other teams. Therefore, a broken build has always the highest priority and needs to be fixed immediately. One of the strategies we can use to avoid broken builds is the gated commit. When we use gated commits, then the build server will take your new committed code. It will reintegrate your code with the rest of the code, but without committing it to the version control yet. It will then build your code, then execute the unit tests, execute the code analysis, and also the security analysis. If everything is good, then the build server will commit your code into the version control. If not, your code comes back to you and you get notified. With the technique gated commits, you can avoid broken builds. I have already mentioned that we need to also execute static security checks. They are summarized under the term application security. Here we are going to statically analyze our source code for security vulnerabilities. But not only our source code needs to be scanned, also the packages or the libraries that we are using need to be scanned. Because what can happen is that in the chain of libraries that we are using, one of the library has a security problem. Therefore, we need to check the application security. The output of the build step is a deployable artifact. But not only that, it is also the feedback to the developers. From the develop step, we came with committed code. This committed code needs to be first reintegrated with the rest of the code, then built, then we need to execute the tests, then we execute the code analysis and also the security analysis. And only if everything is okay with the committed code, then we can create out of that a deployable artifact. There are many tools out there which support us in continuous integration. You can see them down here in our periodic table of the DevOps tools. When it comes to application security, then we have these tools here which can be used, which can automatically check if our application has vulnerabilities. The Safe for DevOps Health Radar is also an assessment. You can download the assessment in this link. It is an Excel table where you can assess yourself in the Safe for DevOps Health Radar in all the different activities. Build is triggered at the moment of check-in and involves compiling, unit testing and other forms of component level validation, successful merging to trunk and main, committing to the repository and producing deployable artifacts. Please rate your team's effectiveness at building and integrating continuously. You are a SIT when builds are run fewer than once per iteration or sprint and are completely manual. You are a crawl when builds are run once per iteration or sprint and are partially automated. Dev branches are open for a month or more and builds break often. You are a walk when automated builds run once a day. Broken builds are corrected in 2 to 4 hours. Manual unit tests are run against each build. Dev branches are open 2 to 4 weeks. You are a run when builds run automatically upon code commit. Broken builds are corrected within 1 hour. Automated unit tests are run against each build. Dev branches are merged to trunk every iteration. And you are a fly when build run on every commit. Builds include static code analysis and security analysis. Gated commits prevent defects from entering the version control. Dev branches are merged to trunk on every commit. In the build step, it's all about reintegrating that new code from the develop step and building or compiling that code, running the unit test or the component tests, and then also running the static code analysis and the static security analysis so that we can create a deployable artifact out of that. And with that, we are at the end of this video. Please leave me a thumbs up if you liked this video, and don't forget to subscribe to this channel because I will create a video every week for you.